continue with the topic of proportion in radius. Today we are going to explain what is a directly proportion on inversely and inversely proportion. Okay, remember that the proportion it's when we have two radius and the result of each one is the same. And remember that the radio it's going to be a simple division. Okay, what is a directly proportion? Let's suppose that we have two items. Okay, we have the item number 1 and the item number 2. Okay, and then if the item number 1 is going to increase, the item number 2 is going to increase too. In that case, it is going to indicate that we have a directly proportion. Or maybe if the item number 1 decrease, the item number 2 is going to decrease too. In that case, we are going to have a directly proportion too. For example, let's suppose that I can make 4 cakes in 1.5 hours. Question: how many cakes can I do in 5 hours? Okay, first of all, we need to read the problem and we need to think about this one. We need to identify the items. In that case, we are talking about cakes and we're talking about time. So if I have can make 4 cakes in 1.5 hours, what do you think? Do you think that I'm going to do more cakes in 5 hours? Well, in that case, the logical is going to tell me that yes, you have more time, you are going to make 4 more cakes. Okay, so it means that if one item is going to increase, the other is going to increase too. So we're going to have a directly proportion, and the only thing that I need to do is to make a rule of 3 again. Well, in that case, it's going to be 4 cakes. Okay, it's correspondent with 1.5 hours, and this should be proportionally with what do I have for information for the other radio. Well, I'm going to have the time. It's going to be 5 hours. So my question is, how many cakes? Okay, I need to make again a simple rule of 3. Remember, we need to multiply here and then we need to divide. Okay, so I'm going to write the variable, the unknown, it's going to be 5 hours times 4 cakes over 1.5 hours. Okay, hours is going to be cancelled. The only item that I'm going to have is going to be cakes. Okay, let's use our calculator and then I'm gonna make 5 times 4 divide over 1.5. Okay, here I'm gonna have 40/3. This is approximately 13.33 cakes. This is not equal, this is approximately equal. Okay, this is the answer of that. Now, remember that this is very important. It depends of the context of the problem that you are going to make to give a solution or answer for that problem. If we are talking about cakes and you have this result mathematically, what is going to be your answer? Let's suppose that you have, for example, a business and you can make obviously you make cakes. What about if you have some customer? What are you going to say? You are going to say that you can produce in 5 hours 13.33 cakes approximately, or you are going to say 13 cakes. Well, in that case, you can offer to your customer over 13 cakes. So the answer, depending on the problem, in that case, the answer is going to be 13 cakes. Okay, obviously you can do a little more than one cake, but this is not useful in the real life. Mathematically you can do it, but in the real life the number of cakes is 1 by 1. Okay, well, this is the answer, but mathematically I need to know if I'm right or not. So for that I'm going to look the proportion between the radius. Okay, look at this. I'm going to use 4 over 1.5. I'm talking about this one, the first one, and then it should be directly proportionally with, in that case it's going to be, I'm not going to write 13.33 because if I write this one I'm going to lose a lot of decimals. I'm going to use the here I'll have here the fraction. Okay, so in that case it's going to be 40/3 over 5. Okay, this can be replaced or reduced like a 4 over 1.5. Okay, and remember this one I'm going to make the division, and then I'm going to have 40 times 1, 40 over 3 times 5, 15. Okay, so what is the radio here and what is the radio here? Okay, the radio here it's 4 over 1.5. Okay, the radio is 8/3, as you can see. 8/3. Okay, and over here in this one, what is the radio? Let's write 40 over 15, and as you can see is the same one. Okay, so both fractions are proportionally and directly proportionally because both have the same radio. In that case is the radio 8/3, and here with this one I'm going to know that I'm right. Okay, that my problem was okay, and this is directly proportion. In other hand, let's talk about the inversely proportion. What is that? Well, here it's going to be cases when, again, I'm going to talk about the two items, and then, for example, if the first item is going to increase, the second is going to decrease, or vice versa. If the first item is going to decrease, the second one is going to increase. That's why it's going to be inversely. And what is going to happen that? Well, let's make next example. Look at this. I'm going to write over here. I can paint my room in, I don't know, maybe 3.2 hours. Well, I know it's a lot of time. Maybe it's a very huge room. Okay, so now the question is, in how many times, how much time my friends, I don't know, maybe Mary and John and I can paint the room. I'm sorry, here it's the room. Okay, again, it's first of all, the first thing is to read the problem and think about the logical. If I can paint my room in 3.2 hours, how much time my friend Mary and John, my friends Mary and John and I can paint the room? Okay, obviously we are going to use less time because we are more people. Okay, so it means that when the items is obviously the quantity or people over here, the persons that I have is, I'm talking about just I, and here I'm talking about 3. Okay, it's Mary, John, and I. Okay, 1 person, 3 people. Okay, So in that case, I increase the number of people that I have. But what about the time? The time is going to decrease. Okay, so in that case, I can identify that I'm talking about inversely proportional. Okay, let's start to make the operations. I'm going to write one. I'm going to write people over here. And I'm talking about I, and the time 3.2 hours. Okay, it is going to be inversely proportional with 1, 2, 3. In that case, it's going to be 3 people. And I don't know how many times. Okay, as you can see, it's exactly the same that in the directly proportion, but what is going to be the difference? Okay, look at this. The operation that I'm going to do is not going to be the same. What I mean? I mean that I'm not going to multiply this times this and then divide over this. Okay, so the thing that I'm going to do is to multiply here this by this and then divide this over this. Okay, this is the difference between the other one. Okay, what I'm gonna do, I'm gonna first multiply 3.2 hours times 1 people. I'm gonna write here people over 3 people. People with people is gonna be goodbye, and then I'm just gonna have time. Okay, this hour. Okay, let's do it. In here I'm gonna have 3.2 times 1 is 1 over 3, and then I'm just gonna have 16 15ths. Okay, 16 over 15 hours. That is approximately equal to 1.066 hours. Look at this. I paint all the room in 3.2 hours. But with the help of Mary and John, we are going to make only 1.06 hours. Okay? So the question is how many times? In that case, in difference with the other example, the cakes, well, I need to round it because of the problem. But here I'm talking about time. The time is continuous data. Alright, so in that case, this is going to be the answer. 1.066 hours. I don't need to round it. So that's why it depends on the problem that you need to round or not. You need to make a decision. All depends on the problem. You are talking about, for example, number of workers. Well, in that case, you cannot have 1.5 worker. Alright, so in that case, you need to round. But you are talking about, for example, the quantity of water, so you cannot round it. I mean, it's not necessary. You can talk about in whatever quantity of water that you need. Okay, so it depends on the problem. How to know that it's right or not? Let's write the data that we have. It's going to be 1 over 3.2, and this is going to be inversely proportionally, and 3 over 16 over 15. Okay, in that case, it's not going to be the same like in this example. Remember, the radius, it's the division between this and this and this and this, and that radius should be the same, but this is directly proportion. In that case, we are talking about inversely proportion. Okay, and this is going to be something very easy. The division should be 1 over 3, and here is going to be the opposite, 1615 over 3.2. Okay, let's make the first one is 1 over 3. Obviously, the division is going to be 1/3 of this one. Okay, and the other one, it's going to be 16/15 over 3.2, and look at this. I'm going to have exactly the same 1/3. Okay, with this simple divisions, with this simple division, I'm going to verify that my problem is right. And this is all about directly and inversely proportions.